Welcome to the DIY Honda Garage channel. The DTC U0100 refers to a condition in which the gauge control module cannot communicate with the Powertrain Control Module, PCM, in a Honda Odyssey produced between 2011 and 2017. In automotive terms, the gauge control module is responsible for displaying critical data on the dashboard, such as speed and fuel level, relying heavily on signals from the PCM. The PCM, on the other hand, manages engine operations and communicates with various components throughout the vehicle. Since these two modules depend on each other for proper functionality, any communication fault can trigger this diagnostic trouble code, DTC. Typically, issues arise from wire damage or poor connections within the vehicle's electrical harness, leading to lost communication. This is crucial for vehicle diagnostics and should be resolved quickly to ensure that all instrumentation functions correctly. The DTC U0100 indicates that the communication line between the gauge control module and the Powertrain Control Module, PCM, has been interrupted. The gauge control module is vital as it processes data from the PCM to display accurate information like engine performance metrics and dashboard alerts. Typically, you'll find the PCM situated beneath the dashboard, while the gauge control module is integrated into the dashboard assembly itself. If these two modules cannot communicate effectively, the vehicle may exhibit erratic behavior in instrument readings. Knowing the exact locations of these components is crucial for efficient troubleshooting. Understanding the role of each module not only helps diagnose the issue, but also assists in identifying potential wiring problems or connection issues that may be at fault. For the DTC U0100, several factors could lead to this communication error. One common cause is poor electrical connections at the gauge control module, or the PCM, which may be due to corrosion or loose wiring terminals. Another possible issue could stem from the battery condition. An insufficient charge can affect the vehicle's electronic systems and lead to communication failures. Additionally, faults in the wiring of the FCAN, flexible controller area network lines, may disrupt signals between the modules. Sometimes this problem may be intermittent, meaning the error may come and go, complicating diagnostics. Each of these potential causes is important to consider during troubleshooting to effectively resolve the communication issue. When facing the DTC U0100, drivers may notice various symptoms indicative of the problem. One common sign is dashboard warning lights illuminating without an obvious reason, as the gauge control module fails to receive or display accurate data. Also, gauge readings may appear erratic or entirely non-functional. For instance, the speedometer may freeze or show incorrect speeds. Engine performance could also be negatively affected, as real-time data from the PCM may be unreliable. Furthermore, when queried with a diagnostic tool, the vehicle may present communication error codes, specifically the U0100 code, indicating that the signal between the modules is disrupted. Recognizing these symptoms promptly can lead to quicker troubleshooting, ensuring safety and functionality. The first step in troubleshooting DTC U0100 involves using the Honda Diagnostic System, HDS, to clear any existing diagnostic trouble codes. Clearing DTCs is essential to reset the system and begin fresh diagnostics. After clearing, you must turn the ignition switch to the lock position, which is the first stop of the ignition sequence. Following this, move the ignition switch back to the on position, which allows for the vehicle's electronic systems to power up without starting the engine. This process prepares the modules to communicate effectively and allows the technician to gather new data from the system for a clearer diagnosis. It's fundamental to follow this procedure meticulously to ensure that any transient issues are identified. After clearing the codes, the next step involves starting the vehicle's engine. and allowing it to run for at least 5 seconds before turning it off again. This process ensures that the PCM has the opportunity to initialize and attempt communication with the gauge control module after the reset. Once the engine is turned off, immediately proceed to check for new diagnostic trouble codes using the HDS again. If the U0100 code is still present, it confirms a persistent issue. If no codes appear, it suggests that this may have been an intermittent failure. The ability to recheck for codes is key to determining whether the initial condition persists or if the channel is now clear, warranting further investigation into other potential causes. In this step, you will utilize the HDS once again to check for diagnostic trouble codes specifically present in the PCM. This is crucial as it may reveal whether other issues are affecting the PCM that could also contribute to the U0100 code. If any different diagnostic trouble codes are indicated, these codes must be addressed first. They may relate to failures in related components or systems. Addressing any indicated DTCs in the PCM can help eliminate additional variables that could interfere with communication between the PCM and the gauge control module. Following these codes will guide the technician toward a more comprehensive understanding of underlying issues and how they interrelate. Next, turn the ignition switch back to the lock position to prepare for further diagnostics without power interference. Using the HDS, jump the SCS System Commercial Service line, which allows the technician to bypass certain safety features that could otherwise prevent disconnections during testing. Once the SCS line is jumped, detaching the PCM connector A, which contains the necessary pins for diagnostics, is essential. Similarly, disconnect the gauge control module's 32P connector. These disconnections allow for direct testing of wiring continuity without interference from other components. This procedure lays the groundwork for detailed continuity testing between the two modules and helps pinpoint where communication may be breaking down. In this step, check for continuity between specific terminal pairs to verify the integrity of the wiring between the gauge control module and the PCM. You will measure continuity across terminals number 19 and number 20 on the gauge control module 32P connector, and compare these to terminals number 48 and number 49 on PCM connector A. Finding continuity indicates that the wiring and connections between these key components are intact and functioning properly. If continuity is confirmed, it's an indication that the communication pathway is functioning as expected. Conversely, if continuity is missing, that points towards an open wire or poor connections within the FCAN communication circuit. Warranting repairs. This specific testing is significant in isolating the problem to either the harness or the control modules themselves. If continuity tests passed, the next action is to substitute the suspect PCM with a known good unit for further diagnostics. By replacing the PCM, you can determine if the original unit was faulty. If the DTC U0100 clears, it confirms that the original PCM was indeed defective and should be replaced. If the code still persists, this directs attention toward the gauge control module or other wiring issues. The act of substituting like components is a common practice in automotive diagnostics, known as component substitution, and aids in accurately diagnosing electronic issues without making unnecessary replacements. Understanding the flow of communication in this diagnostic process helps clarify where failures exist, allowing for efficient repairs and minimizing downtime. After making necessary repairs or component replacements, it's essential to conduct a final verification to ensure that the repair was successful. Begin this stage by using the HDS to recheck for any diagnostic trouble codes. If the U0100 code is absent, this indicates that the communication between the PCM and gauge control module has been restored effectively. The next step involves running diagnostics to verify that both modules can communicate without issues, confirming their functionality. Following this, it's crucial to test all relevant vehicle functions associated with these modules, such as gauge readings and warning lights. This ensures that the entire system is operating correctly and confirms that the initial issue has been fully resolved, providing peace of mind for both the technician and the vehicle owner. Preventive maintenance is critical in mitigating future occurrences of DTC U0100, specifically by regularly inspecting the vehicle's wiring and connectors. Regular visual inspections of the wiring harness can help identify any signs of wear, fraying, or corrosion that could lead to communication failures between modules. Ensuring the battery health is also essential. A weak or failing battery can result in a cascade of electrical issues, including loss of communication. Keeping all electrical connections clean and free from corrosion will significantly help maintain proper functionality of both the PCM and gauge control module. Implementing these maintenance practices will not only extend the longevity of these components, but also enhance overall vehicle reliability and performance. To conclude, DTC U0100 signals a significant communication breakdown between the gauge control module and the PCM in a Honda Odyssey from 2011 to 2017. Potential root causes primarily stem from wiring problems or poor connections, necessitating thorough testing and component checks to resolve. Following the outlined troubleshooting steps methodically helps in isolating the issue effectively. It's also paramount to remember preventative measures, as regular maintenance reduces the likelihood of such issues from arising again. This comprehensive diagnostic approach not only fixes the immediate problem, but also optimizes vehicle functionality and longevity, providing a better overall ownership experience. Please like and subscribe to the channel. See you next time.